Hello everyone, back again with me, Sir Julius, in physics class. So for today, we will learn types of motion, from uniform motion to non-uniform motion. So without further ado, let us start our lesson today. Have you ever noticed how a clock ticking? So if we see the clock, the second hand of the clock, we will see it will move continuously and consistently. So if we assume that the move is consistent, it is one of the uniform motion. After we see the example, so what is uniform motion? So uniform motion is a type of motion where the velocity of the object is constant. Okay, so for today we will learn about one of the uniform motion. We call it uniform linear motion. So what is uniform linear motion? So we've already learned that uniform motion, velocity is constant. It covers equal distance in equal intervals of time. And we've already learned about linear motion. So linear motion is usually called rectilinear motion. It's a motion in a straight line. Because the movement is in one-dimensional only, we can assume that the velocity is equal to the speed of it, because the distance and the displacement will be the same. And because the velocity or speed is constant, we can say that the acceleration atau percepatan in Indonesia is zero. In uniform linear motion, the graph will be linear. So we can see in the picture, for velocity over time graph, we can see the graph is a parallel line with its x-axis. Why? Because the velocity or speed is constant over time. And now this is graph for distance over time. We can see the graph is linear. So the distance is changed over time consistently. One of the example of uniform linear motion is when we go with an airplane. So in the airplane, when the altitude is constant, the airplane will move with constant speed. So the movement of the airplane is uniform linear motion. Okay, so now we will see the formula of it. So S equals to V times T. So S is distance in meters, V is speed in meter per seconds, and then T is time in seconds. Now we will see the example. So how long does it take a bird traveling at 30 kilometers per hour to go 120 kilometers? Okay, so now let's see. So we have the speed is equal to 30 kilometers per hour, and then we have the distance of it is equal to 120 kilometers. Now let's put the formula here. So we have S equals to V times T. So we can change it because the question is T. So time equals to S distance over speed. So we have the distance is 120 kilometers over the speed of it is 30 kilometers over hours. And then we have 120 divided by 30, we have 4. So we have 4 hours. So this is the answer of it. So now for our next topic, we will learn about non-uniform motion. When we go to other places, we usually use our motorcycle or car. But have you ever noticed your speedometer in your motorcycle or car? When we twist our throttle in motorcycle, or when we step on our gas pedal in the car, we notice that the velocity is increasing over time. Meanwhile, when we see the red light in traffic light, we will squeeze our brake on our motorcycle or step on our brake pedal in car to make the velocity of our vehicle decrease till we stop or hit zero mark. So the movement of our vehicle when we step on the gas pedal or brake pedal is called non-uniform motion. Okay, so what is non-uniform motion? So non-uniform motion is type of motion where the object travels with varied speed. So we will learn about one type of non-uniform motion. We call it accelerated motion. So accelerated motion is when velocity is changes over time. Especially for today, we will talk about uniform accelerated motion, when the acceleration is constant. So there are two types of acceleration. The first one is called acceleration, when the velocity or speed of the object is increased. Meanwhile, the second one is called deceleration, when the speed or velocity is decreased over time. So now let's see the acceleration graph. So in this uniformly accelerated motion, this is the graph. For distance over the time, we can see the graph is curved. And then for velocity over time, the graph is linear. And then for A over T, the graph is parallel to its x-axis because the acceleration is constant. Now for the next one, we will talk about deceleration. So deceleration is when the velocity or speed is decreased over time. When it is deceleration, the acceleration is negative. Okay, so we can see the graph in the picture. So for distance over time, we can see its curve. And then for v over time is the same linear graph, but it's decreased because the velocity decrease over time. And for a over time, we can see that the acceleration is negative. So it's parallel to its x-axis, but the value of the acceleration is in negative axis. So we've already seen the example of accelerated motion earlier, when we drive our motorcycle or car. We'll see another example of accelerated motion. Another example of accelerated motion is when we see the movement of an airplane. When the airplane is taking off, the velocity of it will be increased. So it is an accelerated motion. Meanwhile, when the airplane is landing, it will decrease its velocity. So we call it a decelerated motion. Okay, so this is the formula for uniformly accelerated motion. So we must remember that the motion is in one-dimensional only. So we can assume that the velocity and the speed of it will be the same. So we have terminal velocity or terminal speed, kecepatan akhir, equals to initial velocity or speed, sama dengan kecepatan awal plus A times T, plus percepatan kali waktu. And we have the second formula is terminal distance equals to initial distance plus initial velocity times T plus half of A times T squared. Jadi jarak akhir sama dengan jarak awal ditambah kecepatan awal kali waktu tambah setengah kali percepatan kali waktu kuadrat. Nah, so the initial distance always zero. So we can write it as s, or distance, equals to initial velocity times t plus half of a times t squared. And the last formula is terminal velocity squared equals to initial velocity squared plus 2 times acceleration times distance. Atau kecepatan akhir kuadrat sama dengan kecepatan awal kuadrat tambah 2 kali percepatan kali jarak. So now we will see the example. From rest, a car accelerated at 8 meter per second square for 10 seconds. A. What is the position of the car at the end of the 10 seconds? And B. What is the velocity of the car at the end of the 10 seconds? So velocity and speed is the same. Okay, so we can write it as velocity or speed. Okay, so we can write it. So the initial speed is equals to 0 meter per second because it's from rest position. And then the acceleration will be 8 meter per second square. And then we have time is 10 seconds. So now for A we must find the distance of it. So we can write it using this formula. V0T tambah setengah A kali T kuadrat. So we have the distance of it. So initial speed is 0, and then the time is 10 seconds plus half of A is 8, and then T is 10 squared. So we can write it into 0 times 10 equal to 0. Half of 8 is 4, so plus 4 times 100. So we have 400 meter. So the distance of it will be 400 meters. Now for the next one, we will find the terminal speed atau kecepatan akhir. We can use this formula V0 tambah A kali T. So we have the initial speed is 0, and then the acceleration is 8, then the time is 10. So we have 8 times 10 equals to 80 meter per second. So we have the terminal speed equals to 80 meter per second. Okay, so that's it for today. We've already learned about uniform linear motion and uniformly accelerated motion. So I'll see you again next time. Bye!